All right, this is how you find the area of a sector and the length of an arc. And finally, how many radians the angle is worth. All four of these questions are very similar to each other. Let's take it one step at a time. To find the area of the sector, or this little slice of pizza, it would not be, the area would not be pi times 144. That would be the area of the entire circle, pi r squared, pi times 12 squared. For the area of just the sector, it would only be part of the entire area. And you're going to use the 15 degrees. It's 15 degrees out of the 360 degrees, and that would be the area of that sector. If you reduced it, it would come out to be exactly 6 times pi. If you plugged it into the calculator and rounded the answer, it'd be about 18.8. So that's how you find the area of a sector. To find the length of the arc, I'll do that in blue. To find the length of that arc right there, the arc length would not be pi times 24. Pi times 24 would be the entire circumference of the entire circle. We just want only this part right here from C to B. So just very, very similar to the last one, I don't want the whole circumference or the whole perimeter. I just want part of it. What part do I want? I want 15 degrees of the 360. And that would be the answer right there. And you could reduce that by plugging it into the calculator, and it would give you an exact length of 1 pi. And if you wanted to round it, the length would be about 3.1 meters in this case. All right, and then finally, to find out the measure of the central angle in radians, we're going to use, so the last part of the question says to find out how many radians it's worth. We're going to use this radian formula. The number of radians an angle is worth is the arc length divided by the radius. So for this circle right here, we just found out that the arc length was pi, 1 pi. And we know that the radius is 12. So I just have to take those two and stack them up. It's the length divided by the radius. So pi divided by 12 would be the answer. Well, how about one more? If you think you know what you're doing now, maybe try on your own. Let's tackle one of these two at the bottom right here. How about this one right here? Pause the video if you want to, but I'm just going to go ahead and continue on. So let's see. Do you know your stuff? What's the area of this sector right here? All right, so how much space is that taking up? It's not pi times 9. That would be the whole circle. This would be only 150 degrees out of the 360 that we want. So if you reduced it onto the calculator by plugging it in, you get that it's worth exactly 3.75 pi. If you wanted to round on the calculator by plugging in 3.75 times pi, you would get about 11.8 meters squared for the area. All right, moving on to the next part is the arc length. How long is it on the circle from point A to point B? Okay, it's very, very similar to the one I just did, except we're going to be splitting up the circumference. So I know that the arc length does not equal pi times 6. Pi times 6 is the entire circumference. This is only going to be part of it, 150 divided by 360. So if you dial that up on your calculator, you get exactly 2.5 pi. which you could type into the calculator to get a rounded answer of about 7.9. And then finally it says to find out how many radians that's worth. The formula for the radians is the length over the radius. And we've actually done all the work. We just have to divide the arc length by the radius. What's the arc length? We've got it right here. So the radians would be 2.5 pi divided by 3. And it would be okay to leave it like that, or divide it, plug it out in the calculator and divide it. All right, let's review some facts about circles. It says that angle D is worth 25 degrees. If that inscribed angle is 25 degrees, the arc would be worth twice as much, 50 degrees. But the central angle would be equal to the measure on the arc. That's the way angles work. For question D, for question B, if it's 15 degrees here in the picture, notice I'm putting it in the picture, and I'm looking for angle X, I guess there's a few ways to figure this out. One of the cool things to think about is that this triangle right here, I'll highlight it in blue. This blue triangle is definitely an isosceles triangle because I've got two sides that are equal to each other. Both of these two sides here are radii or radiuses of the circle. So if these two sides are the same, if it's 15 degrees in this angle, it would have to be 15 degrees over here as well. And every triangle has 180 degrees total. So I got 15 and 15 makes 30, and I need 180 altogether. That means that angle X would have to be worth 150 degrees. And that's one way to figure out that one. For question C, they're giving me that there's a right angle in the picture. And look at that, they've even marked it in the picture for me. And they want me to find out how big angle X is worth. Alright, so if it's 90 degrees here as the central angle, I can find out how many degrees it is here on the circle, and that could be helpful. That's going to have to be worth the same or different from 90. It would have to be worth the same, since the central angle and the arc will always agree with each other. If it's 90 degrees here on the circle, I can find out how large this angle is here. Since that is an inscribed angle that opens to the 90, I know what X has to be. It has to be worth half as much, 45. All right, let's just do a couple more. Let's take a good look at, what about this one? This one looks like a busy picture right here. It says that AE bisects angle DAC. Well, and they helped me out here. They wrote these little W's here, saying that those would have to be the same measurement. Because if this blue segment here, this blue radius is cutting this white angle in half, both parts would have to be the same. So they call them W in the picture. It says that AD is also bisecting angle BAD. And guess what? It looks like that's a misprint. That should be BAE. My bad. So that means that this would have to also be worth the same amount. Call it W. Alright, so with that little error cleaned up, these three together, those three W's make a straight line of 180 degrees. So I know that the W has to be worth 60 degrees. So these are each 60 degrees, which looks right in the picture. And now I'm trying to find out angle X. Let me highlight that with a different color. I'm looking for this angle right here. in yellow, if I could find out what this is worth on the circle, I'd be all set. And there's a way to get that. If it's 60 degrees here in the center, I know that that arc is worth 60 degrees, and the same as this part here. If it's 60 for the angle in the center, it's 60 on the arc. So I've got 120 degrees right here. That yellow angle would have to be half of the 120 degrees. So angle X would have to be worth 60. I apologize for the misprint there. These are brand new sheets, and I've done a pretty good job editing them, but from time to time I make a small mistake. Let's look at the last one together to round this thing off. It's giving us this picture right here, and they're asking us to find the measurement of AOB. So they want us to find this angle here in the picture using the stuff that we've got. They're telling me that AD is a diameter. I can see that AD is cutting the circle in half. And since that's true, I know that that's 180 degrees here for this arc. And I also know that it has to be 180 degrees total here. So just from that information alone, can I figure out what the yellow angle is? All right, this is not a very easy question to do. It actually took me a few minutes to actually figure out where to go. And what I'll do is I'll just give you the start. And, you know, with these kinds of questions, there are some things you have to look out for. I mean, diameters are a big thing. But also, since we're talking about a triangle formed inside of a circle, you should be on the lookout for isosceles triangles too. And for this picture right here, this is an isosceles triangle. These two segments here are exactly the same size because they're both radii of the circle. And if I got 24 degrees for this base angle here, I know that this angle has to be 24 degrees too. And that'll be enough help to get you going in the right direction to maybe finish answering the question, at least doing question A. And then question B, if you got that far, fantastic. See what you can do with question B using these pieces here. Okay, so that's what I've got here for you on the back, and hopefully you used a little bit of the help to get you stuck and actually get you ready for a short quiz we're going to have real soon.